I have a couple videos on my page that talk about how to solder different components, but a lot of students this year are using more difficult components to solder, like the Raspberry Pi 2040. So I wanted to do a video where I show how to solder that by hand. I'm going to be using a hot air gun because it's really necessary. Unless you designed the pads for the RP2040 footprint to work, you really need to have the to do a solder paste hot air reflow. It's very difficult to do it with a soldering iron because those pads are leadless. You just can't get the tip of the iron in there to deal with them. We will be showing how to clean up a little bit with the solder mesh though. So if you have we will use the iron a little bit to clean that up if necessary. And it probably will be necessary. Sorry, I'm just realizing I got to preheat that. So to start, I'm going to show the apparatus I have here. So underneath here, I have, this is a Quick 853 preheater. So it's basically a hot plate that it pumps out hot air, and the purpose of this is it warms up your entire board. So whenever you're using hot air, the issue is if you have like a if you're using a hot air gun, you won't be able to solder a component on until every pad of that component gets heated up to 230 degrees C. And the problem is a lot of those pads are ground pads or power pads, and the amount of time it actually takes to get a solder joint heated when it's connected to like a power plane or a ground plane is a lot. So what's going to happen is your chip, you're going to have to turn your heat up to like 400 degrees. Your chip is going to be, your chip's pretty much going to be, you're going to have zones of it that's way too hot. Oops, did my video freeze? What happened here? You're going to have zones of your chip that are just way too hot, and in order to get those spots that are thermally coupled to actually get hot enough to melt the solder. So the idea here is that we will that will preheat the whole board so that everything is really close to being up to the point where it's melty. So if you get everything, including the ground planes, up to about 180 degrees C, then it only takes a little bit of extra heat to get those melty. So it lets you solder and desolder components without having to get regions all the way up to 320 degrees C or something, because that's the point where you're going to start to damage silicon devices. So the preheater's down here. It's got a little dial. I'm going to set it to about 200. One of my concerns right now is it blows hot air up, and so we have a digital microscope over it, and so it's basically blowing hot air directly into the microscope. So I want to make sure that anytime I'm using this, that my PCB is covering it. So before I get this started, it will be set to 200 degrees, but before I get this going, I want to show the cold stuff on the surface of this first. So, but it's easy enough to turn on. You just set the temperature, set it to warm, and then power it up. So it's just a little dial with a temperature on there. So it's fairly easy to see. And actually I can show you here. Right. So warm or cool, it's good to do a cool down. So when you turn this off, you don't want to just turn it off. You want to set it to cool, let it keep blowing air, let it keep cooling itself down. Dial sets temperature. Even if you set it all the way to 250, which should melt solder, I found it doesn't actually melt solder. So I typically do it around for lead-free solder, I typically do it around 200. For leaded solder, which you shouldn't be using in here, I'll do it around 150. Yeah, so and that's C. That's the temperature in degrees C. So 150 C is 302 degrees. So keep in mind, even when we have this up to 200 C, the heat coming off of this is like a very hot oven. It's almost 400 degrees Fahrenheit. So you want to be really careful whenever you're working with these. You basically have a hot air oven, so anything that's in the way is going to get cooked like it's in an oven. So be careful with these temperatures. I found that's one of the biggest things when people go from Fahrenheit to Celsius is they tend to the reality that the 203 degrees to melt solder, or the 230 degrees to melt solder, that's actually very hot, and a lot of people I think don't fully that's one of the things that people don't always fully appreciate. I'm trying to get the camera to refocus here. Not sure it's going to happen. There we go. Okay, so we're going to start by talking about paste. So I tend to like to, with boards, I tend to like to always just clean them. So I'm going to zoom in here. So I like to clean them. I'm not going to with this one, but especially if it's gold, when it's gold surface, the gold can sometimes get a lot of messiness on it. So we're going to be using paste that has Flux built into it, but even with that, I like to put Flux directly on these pads here. So what I'm going to do is just put some Flux on here across these pads. And a lot of students say, well, if you're using paste with Flux in it, why add extra Flux? And you wouldn't normally do it if you were doing it with a reflow process in an oven. But for our purposes, since we're going to be doing this by hand, it's really nice to have, especially if you can't exactly get solder paste on exactly all the pads, if you're just kind of smearing it on there like we're going to be doing, it's nice to have this functionality. I'm actually going to turn the heat on a little bit here, just to let this hopefully turn on. Oh, I don't have it plugged in. That would help. So I'm going to let this start blowing some heat, and that's going to kind of distribute this Flux. So as this heats up, it's going to, you're going to see the Flux kind of starts to flow a little bit. And I'm just trying to get it, right now it's kind of sappy. It's like tar, and I'm just trying to get it to spread out a little bit across these pads. Yeah, that's looking pretty good. Okay. I also want to make sure my temp still feels good. I think this is going to be fine on the microscope. Okay, so I'm going to set this back to cool, let it cool down. It just floated a little bit here. The other thing I'm going to do is I like to get paste on the chip as well. I like to get solder paste on chips here. So I have a brand new Raspberry Pi 2040 chip. And I'll probably move to a slightly different part of the board and just set the chip on there. Sticky tweezers here. If your tweezer gets sticky, it's best to clean them off early rather than waiting, because if you got sticky tips on your tweezers, that's bad. It's gonna make it very likely you have parts go flying off later. So, and actually, these tweezers are just generally sticky all the way across. Keep in mind that alcohol, most things will come off with alcohol or water in pretty much everything we do. So if you're using alcohol on something and it's not quite getting the goopiness off, try water, although most things in electronics are meant to be alcohol soluble. So normally an alcohol clean is good enough. So, okay. So clean tweezers should be a little easier to manipulate this thing. So you see these are leadless this is a leadless footprint. And if you keep your parts in an environmentally controlled area, usually you can just put these directly on. And in this case, it would probably be okay to just go directly on. But if you can't guarantee that, you normally want to get some flux on the part as well. And so in this case, to get flux on the edges here, you really want to make sure the edges have flux. And so to do that, I'm going to actually place it on the footprint that's already there. So I'm going to take this part and I'm just going to set it in the flux just to get flux not only on the board but on the part itself. A lot of times the pads, especially these types, the pads themselves have a really hard time getting fully fully wetted. So especially if they've been exposed to air, they haven't been in a dry cabinet, they'll start to get carbohydrates, they'll start to get sulfur on the surface, they'll get a film that will prevent the solder from flowing, and so sometimes it'll look like it flowed, but it didn't. So getting Flux on there is a nice, easy way to help minimize that. So I'm just kind of letting this thing take a bath in the Flux here. Okay, flip it around. Oops. So if you flip it around, look, now that's very fluxed now. So now we're ready to actually do the paste. I'm going to deliberately do the paste a little sloppy to show you it's possible. So the paste job I do is going to be messy, and that's by design, or at least I say that's by design. So I have a tube of Flux, and I'm just going to take some out. And you can see now on the microscope view here, okay, so we have it's still a little warm on that surface there. So the Flux is distributing out pretty well. But you'll notice when we add paste to an already fluxed PCB, it really smears around everywhere. Okay. Now, this thermal pad in the middle, here has some through holes on it. And what that does is the through holes provide a little bit of buffer for if there's excess solder on that thermal pad. It's a little bit of a buffer. That stuff will sort of fill the holes there. I don't like to rely on that, though. I don't like to rely on that being the case. So the amount of I put is sort of a very small amount of Flux paste. I tried to put a very small amount. This is too much. So this is too much solder, and I'm going to show you what happens when that happens. It's going to be okay, but oops. But for now, what I'm going to do is, just with that solder that's on there, I'm going to take this chip and set it on the top. So mostly what we're doing here is we're letting the molten solder actually do most of the aligning of the chip and getting it on the pins. And we'll see how well that works out. I'm hopeful that it'll work out okay. Sometimes it doesn't. So next thing I'm going to do is I'm going to get hot air. So I have a hot air gun next to me off camera, and I'm going to set it to 300 degrees. And before I do that, I'm going to set it to 320. Before I do that, I'm going to start my preheater going. So I'm going to turn this to warm. So we're going to start preheating this board now. And it takes a little while. So as we're kind of getting ready, this is going to be doing its preheating. It really does take about it takes a couple minutes to actually get the PCB sort of fully preheated, and you really do want to let it preheat all the way. If you turn the preheater on and then immediately start using the hot air gun, it's not going to do you as much good. The idea with the preheater is we want any ground plane to get fully up to temperature as it can get, and it just takes some time. So it takes a couple minutes, and so as that's going, I'm going to recheck my temp. My temp is still good for the microscope here, and I'm going to start my hot air up. So hot air, I'm setting it to 320. We might find that's not enough, in which case we can always bump it up. So, and I'm setting the air. I'm setting the air to about half. And this hot air station may be broken. Yeah, I think this hot air station is broken. Okay, it's time to stop the video and get a working hot air station. Okay, got a working hot air gun now. So the main thing with hot air guns, this stream of air is extremely hot. You can easily, quickly burn yourself with them. This is one of the ones that has the pump built in. The mistake students make with hot air guns are typically they go too hot. They don't properly let them cool down and warm up. So when you turn these off, you want to make sure they have a chance to wait and cool down. Another mistake students make is they have the air up too high or too low. So you don't want a blast of air that's so powerful that it blows your parts off your board. But if the airflow is too weak, it can do two things. If it's too weak, by the time the air makes it to the part, it's cooled down a lot. The other thing that'll happen if the airflow is too weak is it's difficult for the heater to regulate its temperature. So if it's difficult for the heater to regulate its temperature because there's just not much air moving through it, it can cause it to overheat and damage the device. So that happens like with like a hair dryer. With a hair dryer, if you clog up the flow of air, the hair dryer can burn itself up. It's the same thing here. So be sure the temperature. So right now my airflow is set at 3 of 8. And my temperature is set to 320. So we're gonna start soldering now. It's had time. I turned the camera off, turned the video off. It's had time to start reheating here. So let's take a look at how this goes. So now I don't have to use tweezers yet. And so I do want to make sure as I'm blowing hot air on this that it's slow enough that, oh yeah, look at that. See, it already got, even just at 320, it's already started melting here. Right. But a lot of students, they see it start to melt and they say, oh, okay, game on. It's all done now. And that's not normally the case. You got to give it a little time. You got to let it fully melt here. And importantly for us, there's a ground plane on the back, so we want to make sure that ground plane melts too. So now I'm going to start poking this thing with the tweezers. And you notice as I poke it, little bubbles come out and it's kind of readjusts itself. So it will self-align, but it's not perfect. So okay, so holding it on there, that looks pretty good. I'm going to give it a squeeze. Squeeze and a big bubble came out. Now it got misaligned. Now it looks like it's realigned. Give it another squeeze. Pop it back, let it realign. And using flux really helps this properly align too. So using the right amount of flux really helps it get alignment easier. This feels right. I'm going to let it cool down now. Okay, and with this particular hot air gun, when you set the gun back on the stand, it lets itself cool down. So, okay. So I'm going to leave for now the hot air blowing, the 200 degrees C hot air. But you see how quickly that went, right? So because we were using the hot air, this thing very quickly, oops, we're drifting here. This thing very quickly did its business and got, oops, whoa. That was weird. The locks on my spring load on this thing went wonky on me. Okay, so now we got to clean up these bubbles. Now we got these the bubble issue. We're gonna have to clean these up. So to do that, now the one thing to note is once these things are, let me tilt this in an angle. Once these things are in place, they're pretty good. So a lot of students worry that they're gonna suck. When they're sucking these little bubbles off of it, they're worried that they're going to suck so much solder that it loses its solder connection to the board. That's not normally the case. That's not normally possible. But you do notice we do have these bridges here. So to do that, to get rid of these, I'm going to get a fine flux paste here. So, oops, let me put it here. So the fine braid stuff, make sure the tip is clean. I'm not going to add too much extra flux. We already have a lot of flux on here. So I'm not going to add too much extra flux, but I am going to put flux on here. So I am going to make sure that the tip of this thing has flux. And now I'm going to take the soldering iron, make sure it's clean. It's good to make sure you got all your sponges in place before you start using this stuff too. Another mistake that students do a lot that ruins our stuff is they don't properly use a wet sponge. So if the sponge at your soldering station is dry, it's tempting to just start scraping at it, to just scrape on the dry sponge, but all you're doing is burning the sponge. So the sponge has to be wet in order to actually wipe the solder off the iron, instead of just scraping it off by burning the sponge, in which case it might as well not be a sponge. It could just be a block of wood, and you could be scratching the block of wood with the soldering iron. So make sure the sponge is wet. We usually keep jugs of water. I did not make sure the sponge is wet before I started, so I'm going to run out to the drinking fountain and quickly wet this really quick. See, if you're quick enough, you can wet the sponge without the door closing on you. And that's the key. That's what I want you to learn in engineering, is to run fast enough to wet a sponge without it. Okay. So I have this soldering iron now, my braid with the flux all good. And now it's a little tough for me because when I use the microscope as an input to the computer, I can no longer see the screen. You see, it just shows that. So it's going to be, I'm going to have to kind of look at this might be a little weird as I do this. So see that? That was all it took. That was all it took. Clean that excess solder off. Okay, so I think that's good. So my next step would be to, that feels good, it looks good in the macro view, but now it's really important to really get in here with the micro view. And let me see if I can adjust this a little bit. Looks good. That looks good. Those edges look good as well. So I would consider that a successful solder of the Raspberry Pi. Now I'm going to set this from warm to cool and let it kind of cool the board down the same way it warmed it up. And then I'm going to show you also how this sort of, I didn't show this before, but basically this board holder is spring loaded. So one side of it, the mounts have little springs on them. It's probably cool enough now. One side, the mounts have little springs, so if you can see on the zoomed out video there, you can squeeze those to the side and then free it. Yeah, and that all looks pretty good to me. So I would consider that a successful solder. I might go take a peek under the good microscope just to verify this. But for right now, this looks like a successful solder of the Raspberry Pi 2040. So that's how I'd recommend you do something like that if you have to do it by hand without a stencil. Thank you.